just do this, your assignment wise, looking at page, it's gonna be page 806 again, where it starts. And you know what? I don't think I'll make this due until next month for you. How's that sound?
Yes.
Okay, make it due next month, all right? 25 through 32. And this won't be due until Monday, which will be December, is that the 2nd? First?
Isn't it?
You're probably right, Mrs. Miller. Yep, December 1st. Told you, not due until next month, all right, guys? Not due until next month. Thank you, Mr. Parkinson. All right, then, fine, be that way. Oh, just be that way. Oh.
Thank you, Mr. Parsons.
You're welcome.
8 problems is a lot, so we might need another day after that.
Wow.
Well, you gotta eat turkey, and turkey will make you tired. Should probably go December 2nd, huh?
Yeah.
No. You guys have that down?
Let's make a bet. After a 4-day weekend, how many people are going to have that done?
I'm gonna say 100%.
I'll take
100%.
that bet.
All right, don't fail me, guys. 100% done. Okay.
I don't know. What do
All
we
right.
need?
Hey, I want to get started this way today. Here's the deal. I want you to think about what we talk about today in terms of about what I'm going to show you here. Here's the deal. You guys have been home in the summer times, right? And you've seen some kind of awful television like the Maury Povich show, or if you stay up late night, you might see that Jerry Springer is on TV or something like that.
Dude,
or
he's on during the
some of
day.
the court shows, like some of the court shows. You guys ever watch those at all? Some of the court shows?
Yeah.
They're kind of comical, aren't they?
Yeah.
Think, oh my goodness. All
The
right.
judges all want to be actors. It's a joke.
Yeah.
Yeah, it's funny, but
Let's do Monday, December 1st.
one thing I'm not gonna lie about is sometimes the Price is Right catches me a little bit, and people are always wanting more, aren't they? Or something like, let's make a deal. Well, here's the deal. If you can kind of imagine today being a game show, here's the deal. I'm going to kind of go up here and say that we're going to play a game here, okay? And we're going to pretend that you get all the questions right. And then you're going to have a choice of where you can take money from, okay? And what I'm going to do is this. I'm going to say that there's 2 sets of money, right? There's a set of money up top, there's a set of money on the bottom, right? In this set 1, where all the money is, let's just say that there's some $5 bills. This is how many $5 bills are up there. Okay, there's 3 $5 bills. Okay, I'm going to say there's some $10 bills up in here. I'll say that there's a $20 bill up here. And I'm going to say there's a $100 bill in here. Okay? Now in set 2, I'm going to say that there's a $5 bill. I'm going to say that there's a $10 bill. I'm going to say that there's this many 20s in the second set. And in this set, there's also going to be a $50 bill, a couple of them. And then finally, there's a $1,000 bill in this set. Okay? Now, here's the deal. Question 1 would be like this. If I said, here's your question. What is the capital city of, say, capitals, states and capitals? I used to know all of them. Let's pick a tough one today.
Oh, man.
Let's pick a tough one today. States and capitals. Let's go Florida. How many of you guys know the capital of Florida? Mr. John?
Tallahassee.
Tallahassee is correct. So John, for winning that first question, you get to choose your $5 bills from set 1 or set 2. Where are you choosing them from?
Set 1.
Set 1, because we're all greedy, right?
Yes.
Okay, why are you choosing from set 1? Why are you choosing your $5 bills from set? There are more of them. I want them from this set. I'm taking them from here. Now, if you can have them from one set, that means you just can't have them from the other. Okay, so we're taking these 5s up here. All right, so question 2. Should we stay with the states and capitals thing?
Yes.
Kentucky.
Oh, no.
knows the capital of Kentucky?
It's similar to the name of a German hot dog.
Yes! For the $10 bills, Max. Say it loud and proud, though.
What's that one?
Huh? Well, no.
You gotta say
The
Frankfurt.
capital city.
Frankfurt.
Frankfurt, Kentucky. Okay? Where do you want your tens from then? Because that was the $10 question. Top one? Because there's more, right?
That should've been the top.
Oh, I don't want you. I want you. Okay? All right. Let's,
South Carolina.
South Carolina's a good one.
So they make a lot of
Starts with
coffee.
C.
So they like a lot of coffee.
No, you're so close. That's West Virginia.
It's where they make a lot of coffee.
Who knows who makes a lot of coffee?
South America. Think about South American country that make a lot of coffee.
Starts with a C.
Say it. Colombia.
Columbia. Okay, that was the $20 question, Fratsky. Where are you taking your 20s from?
Set 2.
Because there's more of them, right?
Yeah.
Okay. Vermont.
It starts with an M, folks. And it's a really weird name.
There's 2 words.
Oh.
Really, it's one word, but it sounds like 2 words. Nope. The Mott's part is right.
Montgomery, Alabama.
Don, you should know this one.
Come on, Vermont. Somebody knows it. Mont's. An
Montgomery.
apple.
Dealer. He said something.
An apple.
Say it,
Montpelier.
Max.
Montpelier. Very good. Okay, that was a $50 question. Now, are there any 50s up here? So where would you take it from?
Aaron.
Where would you take it from?
Set 2. Last one should be like. We'll give you an easy one.
Let's go over the $100 question. An easy one?
Well, neighboring state. Let's go with Illinois.
Starts with an S.
Springville.
Close. That Ville, we got a lot of corn fields, so Springfield. Very good. Okay. Where are you choosing your 100 from?
What's that one? You guys all need to go back to 2nd grade. 'Cause that's when we learn.
Let's skip the presidents.
Do you know them?
Yeah.
You know
Yeah, he does. I don't think you can fool him on that. How about the state of Washington for the $1,000 question? Starts with an O.
And they do this thing like kind of like
4 years.
every 4 years. Ish.
Or every 2.
Close to it.
Winter and summertime. Sounds like it.
Sounds like
Anna,
it.
you look like you want to spit it out. What is it? Oh, you're close. Olympia. Very good. Okay, that was a $1,000 question. So where are you taking your thousands from here? On the bottom. Okay. Well, guys, yeah. If you were in a game show and you were saying, I got to give a question right, and then I have a choice where I want to take the dollar amounts from, you would take it from the set that offered the most amount of money, right? Okay. Well, that's going to be the kind of the concept today. We're going to start breaking numbers down, and we're going to start asking ourselves the question, where could I get the most of? Now, guys, you can read your title of your notes. First of all, what's the title of your notes even say there? Up
It's
top.
called multiple.
Says least common multiple, right?
Yes.
And with least common multiple, what I maybe want to do here is write down that, how many of you have heard the saying before, less is what? Ever heard this saying, less is more? In this section, I want you to think of least common multiple of less is more, okay? Okay? We're going to start talking about multiples today and not factors. We've been talking about greatest common factor, or what are the factors, or numbers that divide evenly into that. Now, I want to make sure we understand the difference here. If I had to ask you guys, and I'll do this over here on the right, or on the left, if you will. If I made a T-chart for 10, what would your factors of 10 be? What would your factors of 10 be? What and what to make 10, first of all?
1 and 10.
1 and 10 to start. Is there another set there, Kyle?
2 and 5.
My factors of 10 would be 1, 2, 5, and 10 then, right? These are my factors that I'll put up over here on the left. Okay, so I should probably put it up here. So just to make sure we understand the difference. If I said, what are the factors of 10? You would say 1 and 10, 2 and 5. Those are the values that would divide evenly into 10. These are considered factors. So today I want to switch gears and start talking about what multiples mean, okay? Multiples of 10. Here's the difference. Factors are the numbers that divide evenly into 10. Multiples of 10 mean you're going to start counting by tens. You're multiplying by 10. So 1 times 10, what is that? 10. So let's suppose you had 2 tens. What's that going to be? 2 times 10. Come on. 20, right? Basically, multiples of 10 simply mean, and I should write that up here, multiples of 10 just means you're going to count onward by values of what? Well, values of 10. Okay? So what's going to come after 20? What's going to come after 20? What's the next multiple of 10? If it goes 10, 20, what's 10 times 3 going to be? 30. 30. What's after that?
40. 50,
How about after that?
60, 70, 80.
You're just counting by tens, right?
20.
Okay? So if I had to say the multiples of 5, wouldn't it go 5, 10, 15, 20, 25, 30, 35, 40? How long is it going to go?
Forever.
Forever. Okay? Factors. There's a certain number of factors of 10, but multiples of 10 will go on forever. You understand the difference between factors, which we have been looking at, and now today what we're going to start looking at here in terms of multiples? Everybody okay with that? Okay, let me check something, make sure. Yep, I'm good. All right, so here we go. Let's start looking at this first page real quickly and make sure we understand what our goal is. First of all, goal-wise, we want to use prime factorization. So we're still using factor trees. Use prime factorization to find the least common multiple, keeping in mind that less is what today? More. You want to choose the most of what we can. I'll show you an example here in a second. But first of all, we need to understand what a multiple is. We just got done talking about it. Multiple is going to be the product of the number and any non-zero whole number. So for instance, as an example, if I want multiples of 6, what would 6 times 1 make?
6.
What would 2 6s make? 2 times 6.
Come on.
And then the next one would be 3 times 6, which would be 18, 24, 30. Okay, and then so on down the road. You just keep adding what value to the previous one? Just keep adding 6 to the previous one, right? So what would be after 30 there? 36. Okay, common multiples then. A multiple that is shared by 2 or more numbers. Makes sense. Common multiples. All right? This is what we're going to focus on a lot today. Least common multiple. Least common multiple. Right here, kiddos. Says it's the smallest common multiple shared by 2 or more numbers. Okay? So least common multiple shared by 2 or more numbers. So I want to jump down to this example 1. And I want to find the least common multiple. Okay? We're going to do this 2 ways. We're going to list stuff. And then we're also going to use prime factorization. And this is the one that you're really going to want to pay attention to on the right side here. Prime factorization. That's the biggie today, okay? Okay? So prime factorization and listing. So let's go ahead and talk about this. What are we trying to find the least common multiple for? What values? 6 and what? Let's find the least common multiple of 6 and what? 14 by the following methods. Listing. Okay. I'm going to put a 6 off to the side here. I'm going to put a 14 off to the side here. Okay, and we're going to list the multiples of 6, and we're going to list the multiples of 14, and we're going to find the first value in each list that's common. Okay? It means what's the very first multiple, what's the very first number that 6 would go into and 14 would also go into. All right, so let's list these. Help me list the multiples of 6, please. No. Start with what value? 6 times 1. Start counting by 6s. What's going to come after 6? 12. 18. I would say list about 6 of them and then come down here and start this one. What's coming after 18? 24. 30. 36.
Go a couple more, Mr. Carson.
Okay. What's after 36, gang? Bad 36. What's after 36? 42, yep. What's after 42?
48.
48.
I think that's good enough.
We'll go one more. 54, okay? There's a good list of 6, right? Okay, now let's start counting by 14s. Let's list the multiples of 14. Obviously the first one being what? Yeah. All right, now if you're not sure, let me pull my calculator up here.
We're good with touchdowns.
Okay. Obviously 14 times 1 is my 14. How about the second one? 14 times 2, what would that be? 28. Okay, now if you start getting up to some bigger numbers like multiplying 14 and 3, which I think you know, but if you didn't, my third multiple would just simply be 14 times 3, wouldn't it? Okay. 42. What's after 42?
56.
What's after 56? 14 times 5 would be 70, right? Okay. Now guys, what I've done is I've listed multiples of 6 and 14, all right? Now, there's no magic rule to say how many multiples do I need to list, okay? Most of the problems you're going to do, I would probably say anywhere from 5 to 10 of them you're going to list, and you should be in good shape. So let's just take a look at right here. Guys, my list that's red and my list that's blue, do you see a number common in each list? And if you see a number that's common in each list, which one's the lowest of the values? If I see a value that matches in the red list and the blue list,
Just say it, Brandon.
42 matches. 42 is my only match, right? Okay, 42 is my only match. Now, that's kind of tedious and kind of hard to do, but what this means right here, guys, is this. It means the smallest number that both 6 and 14 will divide into is what value? 42. So right down below, I'm going to write down the least common multiple between 6 and 14. Sometimes I like to write a 6 and a 14 down here. The least common multiple of 6 and 14 is 42. Okay? That would be if you wanted to list stuff out. So if I said, hey, find the least common multiple of 1005 and 626, I don't want to be listing big numbers like that, do you? Okay. So there's this idea that says, you know what, there's a way to use prime factorization in this. And what you will do is very similar to what we have been doing, okay? Now when you start using prime factorization for the least common multiple, think about that little game show example we talked about. Take the most of what's possible. Find your capital city and then take your winnings from set 1 or set 2, okay? So let's just do this real quickly. I want to break down the 6, and what other value do I need to break down? 14. Okay, here's the deal. Help me break 6. This is really easy. Help me break 6. 3 and 2. Okay? Those are both prime, right? Okay, so my set over here for 6 is a 3 and a 2. Everybody agree with that? Okay, help me break 14 down.
7 and 2.
So my set, those are both prime. So my set for 14 will be 2 times 7. Okay. All right. Here's what I like to do with this. I almost call it like, okay, in set 1 there's a 2 and 3, and in set 2 there's a 2 and a 7. Okay. Think of those as like your money values in there. All right. There's some money values of 2s. There's some money values for 3, and there's some money values of 7 within both sets, right? Okay. So our options are to choose some $2 values, some $3 values, or some $7 values if you want to assign numbers or money to it. Okay. So here's the deal. You answer question 1 right, and that's going to be for the lowest value. Okay. I've got a 2 here and a 2 here. All right. Which set would you take your 2 from, or would it matter? You have the same amount of 2s in each set, right? So does it matter where I take the 2 from if I want to win money? No. So let's say I take the 2 from this set right here. If I take the 2 from this set right here, can I have this 2 then?
No.
No, can't have it. Okay, so we've exhausted the $2 values. I can only choose from one set. Now I've got some $3 values that are in there. All right, where do you want to choose your $3 value from? The left set or the right set?
It's only on the left.
It's only on the left, so I'm going to take that there, right? Okay, so I'm going to take the 3 here. That's good. And then finally, what's my last value that's left to choose from? 7. So take the 7. Take it. All right? Quick question. Why did I take this 2 and cross this 2 out? Well, the 2's are the only values common, right, in each set. So if I chose 2 from one set, can I have the 2's from another set? The answer is no. Okay. Notice the values that I circled right here, gang. A 2 and a 3 and a 7. What am I trying to find again here?
Least common.
Let's check this out. Let's see what this does. This least common multiple. You know, in the past when we were doing greatest common factor, we took what was common and multiplied the stuff that was common, right? So the principle would be the same here. Take what you've got chosen as your winnings, take the most of what you've got or took, and multiply them together. Let's just check this out. 2 times 3 times 7. Oh my goodness. I think I see something here. But what's 2 times 3 going to get us? 6 times 7? Oh my goodness! What's the least common multiple? It works. It works.
Yes, it does.
I'm going to be on that Channel 7 show. Does it really work?
The potato thing.
Less is what today, guys? More. Let's get one where we've got some more values to choose from and see if we can't kind of figure this thing out. Still, kind of the same stuff we've been doing. You got to do your factor trees, don't you? There's just different rules attached to what you're choosing now. What are you going to use? So, let's jump to that second page.
Yes, let's.
All right, yeah. I like it.
John's as excited as you are.
Let's, you know what? Let's do the 8 and 12. Okay, prime factorization, 8 and 12. All right. So I'm going to kind of try and let me zoom this up a bit. All I want to do is zoom, 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 zoom. Okay, never mind.
You're extra.
I saw a funny commercial last night, which dated me. Don't doubt about that, but it was. Have you guys seen the salt and pepper commercial? I thought it was funny. Never mind. All right, 8 and 12. Break down 8, gang.
4 and 2.
2 is prime. 2 and 2. Okay, so how about my list for 8? 2 times 2 times 2, right? 3 of them. Okay, so this is going to be like what's behind door number 1. Okay, there are 3 2's in it. Ooh. All right, let's break it down 12. I'll break it down.
6 and 2.
6 and 2. All right, good start. 2 is prime. 3 and 2. So what's behind door number 2? 2 times 2 times 3. Okay, that's my second set right here, right? Okay. What are the monetary values that you have to choose from? There's some 2's and there are some 3's to choose from, right? Okay. So let's just start with the lowest value first. I've got some 2's to choose from. Where do you want the 2's to come from? Left set or right set? Okay, I'm going to take the 2's from this set right here, right? I want these because there's how many 2's in the left set? 3 and how many here? If I take the 2's from the left set, can I have the 2's from the right set? Yes or no? Nope. So these 2's, don't worry about them. Okay, what's the next value I can choose from? A 3. Where's that coming from? Left set or right set? Okay, take it from the right set here. I want this. Okay, so let's talk least common multiple here. My least common multiple shall be. What are you going to do with the stuff you circled, guys? Okay, so I've got 3 2's. 2 times 2 times 2 times a 3. So mentally, help me carry this out. I need all the help I get. We know that 2 times 2 is
4.
8. 24. Least common multiple then is. So the least common multiple of our values 8 and 12 is equal to what value again? 24. There it is. There it is.
Yep.
Okay. Perfect. The next one's a little trickier. All right. Oops. Back up. Here we go. Next one's a little trickier. Help me break 24 down. Help me break the 24 down.
8, 3.
8 and 3. 3 is prime.
4 and
2 is prime.
2. 10, 2 and 2.
2's are prime. So that set is 3 2s and a 3, right? Okay. Let me break my 29 down.
There's no break.
29's already prime, isn't it?
Yes.
Okay, so this set's just what value over here?
29.
29. Okay, would have been 1 and 29. So help me out here, guys. This one's a nice set. Where are the 2's coming from? Where are the 3's coming from? Where's the 29 coming from?
Right.
We get to use all the values this time, right? Okay? We get to use all the values this time. So just simply 24 times what, basically? Yeah, my least common multiple here would be all these values back. We get to keep the 2's, we get to keep the 3, and we get to keep the 29. So you would have least common multiple of 2 times 2 times 2 times
696.
3 times 29, 720 minus 24. What'd you say, 696?
Mm-hmm.
I agree. I agree. So the least common multiple would equal 696. Okay, 696. Now guys, in this third one I'm going to have you try here in a second. In this third one I'm going to have you try here in a second. What's different about the third example compared to the 2 we just took a look at? There's 3 values, okay? So what I want you guys to do is this. Again, you can only choose values from how many sets? Choose values from how many sets? One set. If you take a value from one set, you can't have them in the others. So what I would like you to do is this. I want you to break down your 2. I want you to, I want you to break down your 2. I want you to break down the 4. And I want you to break down the 14. Find your sets and then use your values in your prime factor sets to find the least common multiple of those 3. So go ahead and take a minute and do that. Once you have a solution, check with a neighbor. If you get stuck, have your neighbor help you out if possible. Okay, gang, how about a solution out there first? Anybody got a least common multiple amongst 2, 4, and 14 for me? Who's got an answer? Brandon, what have you got, kiddo?
28.
I'm hearing 28. Anybody else have 28? Okay, quite a few of us. Good. Okay, so let's break down 2. 2 is already broken, isn't it?
Yeah.
Okay, so this set, it just breaks into 2, so that set is a 2. I'm going to put a, oh, I need my better pen. Hold on, where I set that down at, gang? There it is. 2. Okay, so that set is taken care of. All right. 4 broke down to what? 2 and what? Okay, so that set is 2 times 2 in that set. And what's 14 break down to? 2 and 7. Okay, so our set here, 2 and 7. All right. So give me a second here. I don't like the way I've got this. Whatever. We get it. Okay. All right, guys, so it looks like I've got some values to choose from, some 2s and some 7s. So I've got set 1 on the left, set 2 in the middle, set 3 in the right. Where do you want the 2s to come from? First, second, or third set? Second one. There's more of them in here. So I'm going to take these 2 because I can have them both, which means can I have this 2 on the left? No. So I can't have that. Can I have this 2 on the right? No. I can only choose the values from one set, but this gets us the most, doesn't it? Okay, what else could I take, gang? Take a 7. Okay, that can come from that set. I've exhausted everything. So what are our winnings? A 2, a 2, and a 2, 2, and a 7. So what are you going to do with those values in the end? Well, we'll multiply them, right? That's what I've told you to do. So the least common multiple will be 2 times 2 times what? 7. And what's our product here? 28. Very good. So final solution there, 28 for that one. Okay. Does this make sense?
Yes.
You guys okay with this?
Yes.
All right. Okay, let's look at this application problem here quickly and try a few more. Oh, I need to go there. All right. Guys, since we're close to Thanksgiving, we're going to talk about baking some rolls. Got one baker making rolls in batches of how much, gang? Batches of what? Is everybody with me on example 2? Got batches of 14. One baker makes rolls in batches of 14, and another baker makes them in batches of 16. It says, how many rolls will each baker make when they have the same amount of rolls made? Okay, so we're trying to find the least common multiple of that. And then how many batches will each baker make when they have the same amount of rolls? All right. Well, that's interesting. Okay. First of all, we want to know when are they going to have the same amount of rolls. So in other words, the first thing we need to do is find the least common multiple. Okay. So we need to break down 14 and we need to break down 16. So let's do that. Okay. So I'm going to break down 14. I'm going to break down 16. Okay. Is it okay if I just tell you what those are real quickly? Okay. 14 is just going to be 7 and 2. All right. That's the set for 14. Prime factorization of 16 would be 4 and 4, right? And then each 4 would break down into 2. So how many total 2s? 4 of them. Okay, so like, if you can think of these rolls being on like, here's one pan of bacon and here's a different pan of bacon. One baker puts 14 in a pan, one baker puts 16 in a pan, right? Make sense?
Yeah.
Okay. We want to know when's the first time they're going to have equal amounts if they have full batches. All right. Some 2s and some 7s to choose from. Where are they coming from? What's coming from the right side? Take the 2s from the right, and what else do I want to take? What else do I want to take? 7 from the left. Okay? So my least common multiple shall become, okay, what value is it?
112.
That comes from 2 times, whoops, I don't want yellow there, it's hard to read. That comes from 2 times 2 times 2 times 2 times 7. So there are, the first time they're going to have the same amount of rolls is at 112, right? At 112, right? Okay, now the question becomes after that, how many batches will each baker make? Well, let's go baker number 1. Baker number 1 is making batches of how many here? 14. Okay. So if he's going to make 112 total dinner rolls right there at 14 dinner rolls per batch, what are you going to do with a 112 and a 14 to figure out how many of those pans he's going to have to put together? Divide. So baker 1 will be 112 divided by what? What is that value, gang? Somebody punch that up for me. 8. Okay, so baker 1, 8 batches. How about baker number 2? Baker number 2 is also going to make 112 dinner rolls, or whatever they're calling them. I want the dinner rolls from Texas Roadhouse. Those are the best. Okay. Baker number 2 is going to make 112 total rolls at a 16 per batch. So what are you going to do with the 112 and 16, gang? Divide. How many is he going to end up making? Okay. So baker number 1 would have 8 trays like I have over there with 14 rolls in each tray, right? Baker 2 would only use 7 of those trays over there with 16 in each. Okay. Understand what's going on here? Okay. You understand this idea of prime factorization as it relates to least common multiple? With the idea less being we want to take the most, all right? Least is most today, all right? Okay, you know, been looking at this idea then, how do I take this idea and apply it to monomials? Okay? Principles are the same. So here's an example for you. I want to find the least common multiple. Let's do this. Let's find the least common multiple of the following monomials. Let's go. This would be a good one. 24x squared y, and let's go 30 xy squared. Okay. So here we go with this. The first monomial, 24x squared y, we need to break this down. So help me break down the 24 first. Wouldn't 6 and 4 work here?
Yes.
Okay, beyond that, what's 6 going to go into? 2 and 3. And 4 will break down to what? So do you guys agree that the prime factorization for 24x squared y is the following? 2 times 2 times 2 times 3. Now we got to include our variables. This is where I just include the variables. So look at your exponents attached to each variable. Take a look at this first monomial. How many x's? 2 of them. So beyond this, 2 x's and a what? And a y. Okay, there's the prime factorization for that first one. Okay, set 2. Need to break down 30 xy squared. All right, what's 30 going to break into? How much? 10 and 3. That's prime. How about the 10 then? 2 and 5. Those are prime. So my set for this is going to be 2 times 3 times 5. How many x's, gang, for this one? 1, and how many y's? 2. Okay, now assume the variables are just like the values. They hold some kind of monetary value. You want to take the most possible. Okay, so let's start with the value 2. Where are they coming from? Left side. I can have these 2's, which implies, nope, can't have that one. How about the 3? Where's the 3 going to come from? Doesn't matter, there's the same amount, right? Okay, so let's take it from this set here, which means I can't have that one. There's a value of 5. Do I want that then?
Yeah.
Take it. Now, this is where the monomial part comes into it. Look at your variables. Where are the most x's coming from, left or right?
Left.
Take this one. Can't have this one. Okay, where are the y's coming from? Right side. Want it from the right. There's more over here, right? Okay, so let's put this all together here. I'm going to kind of squeeze my final answer up in the top here, middle. Least common multiple becomes the following. Whoops.
120.
Least common multiple becomes the following. How many 2's do we have, gang?
3.
Times a 3. Times what's the last value we chose?
5.
5. Okay, how many x's are we taking?
2.
How many y's did I take? I'll squeeze it in there. 2 of them times a y, right? Okay, let's put this all together and get our least common multiple. What did this multiply to again, Brandon? What'd you say?
120x to the second power and minus
120x to the second times y to the second. Awesome. So the least common multiple between those two monomials, 120x to the second, y to the second. Okay? Let me ask a question. Is this really that difficult? Just a little bit tedious, isn't it? Going to have to apply some work to it, but I think it's all stuff that we've been doing. If you can just understand the concept change today, you're in good shape. All right? All right, so I'll highlight this. Here is our solution right there. Okay, very good. Very good. Okay, so let's have you try maybe 1 or 2 of these here quickly. Why don't you guys roll off to the next page. And we're not going to worry about the bottom part here yet today. So we'll get to example 4 and probably shut down there. But on your own, find the least common multiples of these monomials here. Let's do the first one. Make sure we're good, and then I'll have you try another one that's maybe more difficult. So let's just go 6 x squared y and say maybe 8 x y z. Okay? All right? See what you come up with there, all right? Take a minute and just kind of work your way through that. Your two monomials being 6x squared y and 8xyz. Make sure you've got them written down as I do. Let's get at least common multiple check for someone. Was it x squared y? X, yeah. Anybody want to come up and do this one? Want to do it? You got it, Lily?
Let me check quickly.
So that should be the Z right there. So you're just gonna have, yeah, the only thing that's different is one point and the Z. Okay. Got it? Want to do it? Yep, you can do it. Okay, Lily, I'll talk you through this. All right, Lily, tell me what you're doing here, all right, kiddo?
I'm going to do
Okay, so 6, we're breaking that down into 2 and 3. Good? Everybody agree with their prime factorization for the first monomial? Excellent, good job, okay. Then do the second one.
16.
Okay, so everybody agree with prime factorization for that monomial? 3 2's, an x, a y, and a z. All right, rock and roll, you're on a roll here. Where are your 2's coming from, Lily?
over here.
Taking those 2's, which means cross the 2 out over there on the left side. Good. How about your 3's? Where's that coming from? Good. And your x's you're taking from the, okay. How about the y? What about the y?
It goes bye-bye.
Doesn't matter where I choose it from? Okay, so it does because it's the same amount. Very good. So take one and get rid of the other. And take the z. Okay, so she's got 3 2's and a 3 there. All right, I'll tell you that the product of that there looks like, what, 24? Is that right, gang? Yeah. So, final solution for me, Lily. You're on a roll. X squared times y times z. Awesome. Awesome. Perfect. Love it. Good job. How many had that? How many at least had the 24 part right? Okay, so we're in the ballpark here. Good. All right, one last example to try here quickly. I think we've got this pretty well. Let's do this on that last example there. Huh?
I don't want to go to PE today.
Oh. Yeah, you'll be fine.
Play a fun game.
What are you guys gonna do? Build a snowman or? No?
No. Enough of the wisecracks, Marshall.
Alright. Sorry. Me's done. Oops, that's a lot of X's. Let's not do that. Alright, go.
Is that a 2 or is it?
That is 12xy squared and 15x to the 4th. Just 2 of them, yep. Split here.
XY squared. What's the first one? Was it XY squared? Come on with 12.
Yep, 12xy squared and 15x to the 4th, yep. we've got about 4 minutes left here, so I'm going to write these down. What was your prime factorization for 12xy squared, everybody? Okay, just tell me your final part. Do you guys have 2 times 2 times 3 times x times y times y? Okay, that would be for the first one. How about your next one here? What's the 15 going to break into? 3 and 5, and how many x's? All right. So the least common multiple. Take the 2's, take a 3. Where are the x's coming from? Right or left?
Right.
How about the 5? I would take this 5, wouldn't I? And take those y's. Everybody agree? Okay, so my least common multiple looks like 2 times 2 times 3 times a 5, numerically, times 4 x's, and times 2 y's. So in simplest form, the 2, 2, 3, 5, what was that product? 60. X to the, ooh, careful. X to the what? 4th, y to the, okay. All right, guys. Hey, you know what? This is stuff that's not easy to do, but I think you guys did a really good job on this today. So keep those things in mind. The book page, did everybody get that 806 written down today?
Yeah.
And you guys know what that's not due until Monday when we come back from break, right? Tomorrow we'll kind of have some time to work with this a little bit. There's a quick quiz attached. Just bring that with you tomorrow. I'll probably start class time with that, questions and quick quiz, and some time to work tomorrow, okay? All right. Any questions at all? Going once? Twice? Okay, good work today, everybody. It was great.